Good afternoon, everyone. I'm Scott Fryer, and today I'm going to do a talk that originally started off as a single slide in a presentation about how we do our secure development at Adoptium. It was basically, we have a whole bunch of, I think a total of 55 version and platform combinations. So Windows on ARM, Windows on x64, x86, very much the same for Linux, x64, ARM, 32 and 64, RISC-V, S390X, and basically we have a whole bunch of security processes and things to consider. All our infrastructure is publicly available. So basically, how do we guarantee that infrastructure is secure? How do we prove that and demonstratably actually show that our infrastructure that underpins all of the JDK builds, underpins all of the testing, but the builds more importantly, with the proliferation of supply chain attacks, ensuring our build system, our build infrastructure is as secure as can be, and demonstratably so is vitally important. So I'm going to quickly skip through the agenda, but I'm going to give a bit of an introduction about me and what we do and why we do it. A little bit over the tools that we evaluated for helping us to achieve this, because maintaining a suite of 100 machines is a fairly sizable task for a large team. For a small team like the Adoptium team, it scales massively. And then through some of the key features that we demonstrate, and so on. So, who am I? I'm Scott Fryer. I'm a senior software engineer at Red Hat. I've been with Red Hat for about 2.5 years now and working on the Adoptium project full-time for that period. Prior to that, I've got 16, almost 17 years experience in the UK financial services industry. I've dealt with a lot of regulatory frameworks, secure DevOps, and again, build, source control, auditing, and in the financial services world, all those things are absolutely critical. I now work full-time on the Adoptium project, and mostly I work on producing the Temarin JDK. So a key objective over my time working on this project has been dealing with ensuring our secure software development processes, tools and practices are as good as they can be. So meeting the regulatory frameworks such as NIST SSDF and SALSA has been a key drive, and given my background with infrastructure management as well, bringing that into the infrastructure sphere has been a very natural fit. And why is security important? I'm sure you've heard it 100 times if you've heard it once today. If your base things aren't secure, nothing that sits on top of it is also secure. Any vulnerability of the base operating system of your build system potentially leads to vulnerabilities in your built distributions and binaries. The SolarWinds attack, which is world famous, was a supply chain breach. It was a compromised Jenkins server, I believe. And then all the resultant artifacts with the vulnerability all appeared signed and were all correct, but obviously all contained a major vulnerability. So moving on to tool selection. Looking for an SIEM tool. So a bunch of key features that we really needed to consider. Feature-wise, how compatible is it with our massive amount of variety infrastructure? There's a lot of things if you're just running on Windows or just running on Linux, but running on Mac and RISC and S390X and Solaris is a key feature. If we can't secure the whole supply chain piece, then obviously we've got an issue. Cost effective, we're an open source project. As always, financing budgets are a consideration for everything we do. The threat detection, if there is a vulnerability, if there is a breach of some kind, can we be notified immediately and deal with it? Or ideally, deal with it before it ever gets beyond a threat. Is it scalable? Can we scale it across our variety of infrastructure from a bunch of different providers? Is it capable of reporting those things? So should there ever be a requirement, there may well be in the future, to demonstrate to a regulator or otherwise that we are compliant with various things, then we can do that as well. And in theory, it should be easy to use, quick to use, and yeah, as little effort as is possible, again, for a small team. At Adoptium, after evaluating a whole bunch of tools, things like SNCC for intrusion attacks aren't really an issue when you have infrastructure from 10 different providers, because you basically have to install a system that monitored at 10 different providers, aggregate the results. For us, host-based security was without a doubt the answer. So we ended up with Wazuh. I'm not here to sell Wazuh, but it was the tool we ended up selecting. It is a fork of OSSEC, which used to be open source, and they forked Wazuh when OSSEC became commercially licensed. It's basically the OSSEC engine and threat detection, with the public rules being now driven by the Wazuh community, and the further rule set to deal with all the CVEs and things like and vulnerability detection. So there's a real community kind of background to it there, which fits nicely with Adoptium's open source ethos. And it's got a really nice reporting layer that OSSEC itself actually likes. So it's got the OpenStack, ELK stack, OpenSearch framework bolted on top, out of the box, without any setup. It's a delight. So Wazuh's real-time threat detection is good, I can't actually move on it. So the real-time threat detection, it provides immediate notification of potential threats. So if somebody's trying to brute force a login, it's definitively telling you that immediately, and it has automated response to that. So as soon as we're getting a brute force attack, we can block that IP, wall it off. No action needed from a user. It just does it. The thresholds for all of that kind of thing are eminently tunable, but again, it's a zero effort response to real-time threats. It has a comprehensive vulnerability scanner. So again, we'll see some of these features a bit later, but last week, the week before last, that cups vulnerability was revealed on a Friday morning. Using Wazuh, I audited our entire build farm in less than 5 minutes. Identified any machines that needed patching. There was one machine that had been powered off even before that. So again, it was a case of when we brought that machine back online, we patched it, resolved the vulnerability, and Wazuh showed all of those events in real time. It identified the vulnerability, we patched cups, and we saw the vulnerability get resolved in Wazuh, and you can see that audit trail of events. Host-based intrusion detection, so it basically harvests all of your critical system logs, and which ones those are. The standard ones you know about, you can customize it further if you want to go beyond the normal suite of auditing logs on a typical system. And it's got a set of rules which will parse those logs and again alert and report on those elements. And analyzing the logs, it captures so much information which is extendable. We've added the ability to record the SSH keys of anybody that logs into a server. We use SSH key-based access. So again, we can see who's logged in from the SSH key they've used. And we capture the checksums of those, and Wazuh itself captures what that user's done at any given moment. And again, in a fairly easy to establish way. So why the drive to do this? So this is a fairly recent slide. This is pretty much the last 30 days of attacks on our build farm, which is about 32 machines of just the build machines. Over those 30 days, 3.9 million attacks. 30 days. Most of that are the Windows machines, not surprisingly. Of those, 318 of those alerts are deemed critical enough to warrant a response. 9.1 million authentication failures, which are bad password attacks, people guessing usernames, and the authentication successes. A lot of those, we have a lot of jobs running, a lot of builds running. The authentication successes there, again, just so we can validate what's going on. But 3.9 million events that if we didn't have the monitoring in place, we wouldn't be aware of, and of those, 318 are deemed critical enough.
Sorry, just for context, is the whole farm publicly accessible, like SSH logins?
The IP addresses are public. Our inventory file is public because we are an open source public project. SSH keys and logins on, you don't have access instantly you join the project. We have various policies and processes in place. So just because the IP address is available doesn't mean you have access to a system. Once you join the project and build trust as a committer and member of the project, if you need to work on a machine, you can request access on those machines, and your request will be considered and actioned as appropriate if necessary. So no, not everybody has access, but the list of machines in the inventory, with I think 2 machine exceptions, is entirely public, and that's the joy of an open source project. In my former life, that would have been tantamount to heresy. Even listing a machine name, let alone the IP addresses, would have been. So yeah, this is a thing I've had to get used to. This will be a point that comes back for debate in the future, I still feel. But as long as the approach to security on those machines is good, having the IP address saves a hacker, 30 seconds from IP import scanning. It's not a huge thing having the IP address there, it just saves somebody 30 seconds. But that's a good idea or not, the matter. So we'll look a little bit closer at the intrusion detection. So, intrusion detection access auditing is how we systematically review all the access across a system. And this screen's very, very small. So here, I have a set of rules highlighted. A chunk of the events that I'm particularly interested in, they are 18 authentication successes that are not instantly related, obviously related to the known processes, the known activity on those machines. So things like Jenkins and Nagios and things like that, doing their normal work, logging in, running checks, running builds, all of those things are valid use cases. So in this case, we've identified 18 events, successful logins that we need to look at. So ideally, we're looking for things insider threats. In theory, somebody could join an open source project, contribute for a while as a head of a malicious act. All of these things, we're trying to ensure that they don't actually happen. I'm just going to run through these slides a bit. So if I move on to the next. So in this one, we can actually look at the particular machines that have been involved in those 18 incidents. As it is, there's 5 different machines that we probably need to take a look at, a few Docker hosts, which we use for doing lots and lots of builds, and a couple of other build servers of varying configuration and providers. So we'll take one of those events, and now we can see all of the information that has been captured about one of those login attempts. And we can see, so here, this is Nagios logging in. So we're probably not worried about it. So we will amend our rules and have it so that this particular alert doesn't flag again in the future. I think I've had to put one in just for demonstration purposes. So we can see there, is it readable? So we can see the host name, the user that was tried to log in as, the event itself as a login success, where the attack originated from, timestamps, a whole bunch of events that we can then decide whether that access attempt was valid or otherwise. This one was a valid access, and we'll stop that from alerting in the future. But it's 18 out of 3 million. It's the time versus effort. So a slightly different example. So these are authentication failures. And again, a couple of thousand of those. I think I'm just looking at a single day here. Again, not massively concerned that no access has been granted to these, but again, it's useful to know what's going on, how many attacks, what your attack surface is like for a potential hacker. And again, some of the data we capture there, for some reason, somebody in the Republic of Lithuania would like to attack us today. So again, you can implement geofencing, which again, we're an open source project and open to everybody. But the vast majority, if you do it on and I don't have those charts in this presentation, but the number of attacks from Russia is responsible for probably 95% of our geo-based authentication failures are based in Russia, at least as far as you can tell with people hiding behind VPNs and things. But it's interesting statistical data that lets you shape your security policy to deal with those threats. So that is our access intrusion. It's probably the single key feature we use Wazuh for, and again, it gives us an amount of confidence that our build processes, our build tools are not compromised in any way. Ideally, we'd like to have our build infrastructure completely ephemeral. It exists for the duration of the build and then ceases to be, which is possible for some platforms, but not others. There's no really way to have ephemeral Solaris build infrastructure or S390X infrastructure. There just isn't a Docker or a virtual machine for those platforms, so we are left with physical machines. And even in the case of things like Docker, we still have to have hosts to host our containers. And again, that's just the nature of building OpenJDK. So, second feature I'm going to move on to is vulnerability scanning. And this is how do I identify which system packages have got potential vulnerabilities. And again, this is a quick look at a particular, this is one of our Windows 2022 build machines. And you see there, it's got 0 critical CVEs affecting it, 11 high, 5 medium, and no low severity. So again, there's a whole bunch of stats at the bottom. And it will go further and then show you which packages and which versions are affected and their CVEs, which is very useful for going to look up at NIST. But you don't really have to do that because Wazuh will also go and scrape all that data from NIST for you. And again, it will show you what type of vulnerability it is, if there's a fix available for it, which package it's fixed in. In this case, it's a vulnerability in a .NET package. Again, we know about it. It's not a particular risk for us, but we will know we will patch it out when we next upgrade our version of Visual Studio. We're slightly limited in when we can do that because OpenJDK is tied to building on specific versions of Visual Studio. So we know about it. It's not critical for us, but it's one that we will get patched out. And when we move Visual Studio on, we will make sure those CVEs get resolved. So, and this is a screen I added just the other day because it shows how quick and easy it was to identify all of our machines with a cups vulnerability. It's a single machine. But it took 3 seconds rather than having to run an Ansible playbook or a script that logs into every Unix machine that's got cups installed, check its version, report back, check all the version numbers by hand. You just did it by adding a simple filter to a query. It's yeah, a time saver of, again, when you're managing a suite, time is everything. Next feature that's particularly relevant, and other tools are available, but I say this is just our preferred use case. This shows that file integrity checking. So when a system file changes, and we have processes that run daily, every other daily, that update the system packages, things like Docker, it's just an apt update in this case. But here you see that Wazuh has very kindly told us that the Docker binary has changed. We've got before and after checksums. And again, we would probably go and make sure that a new version of Docker's been available and somebody's not maliciously tampered with it. It's another level of validation that everything is good. As it was, a new version of Docker was released that day. The system picked up the update. Again, it's correct, But again, we can prove all of those things in real time as they happen with little or no effort. And I think this is the final element of the key features that we really rely on. It's threat detection and response. So how Wazuh does this, it has a set of rules. They're community driven, community contributed to. Largely they involve particular strings in logs or particular vulnerabilities. So those security rules are community driven, but you can add your own custom ones, and you can customize existing ones to be more or less important to suit your use case. But that rule-based alerting is what really allows us to drive our security behavior. So it will use the audit logs for the system. It will use your network logs. You can put extra rule-based in on particular files if you have, say, critical config files that you don't want to be tampered with at all. You can have a real high-level alert on that, but you can then also block that action from taking place, or more as it happens, it just reverts it by not allowing that files checksum to change. So again, it's looking for anything that is not allowed beyond the standard set of rules, which is very, very comprehensive, but then you can put your own in to be even more specific to things. Additionally, besides all of those, rule-based alerting, anomaly detection, it's got a set of threat intelligence integrations. So there's a bunch of external things. There's a couple that relate to blocking IP addresses for particular things and blacklists. Wazuh will integrate with those lists if you want it to, and automatically handle the automated response to those things based on the third-party things. It's not a feature we use particularly. The rule-based alerting and the anomalous behavior detection is what really stands out for us, but the feature's there. And so real-time detection, you have almost no response time or very quick response time. So yeah, you reduce your window exposure massively. You can be proactive in dealing with threats. You can be ahead of the attack before. Again, a previous life, somebody opened a bad email which shut a global business down entirely for 9 months, while every single system, every single server was rebuilt from scratch. If a tool like this had been in place, perhaps wouldn't have happened. Almost certainly wouldn't have happened. So it's an investment versus what may or may not happen. And again, the alignment with global security policies and it's a standard set of tools used quite widely. It's been an essential tool in our security battle. So again, you can just see some more lovely sample data of the various roles that are being attacked. So the SSHD, somebody's brute forcing. It's a very popular attack vector, that. And then again, SSHD, attempt to log in as a non-existent user. This, I think, all comes down to the typical attack vectors that scripted-based hacking uses. And again, the detail being captured, IP addresses, target users, geolocations, the usernames they've tried to use. With Windows, it's quite common for people to try and guess the administrator user password. So even something like as simple as disabling the administrator account or renaming it so it's no longer administrator saves you 1 million attacks a day, maybe. It's things like that. And this data lets you see those things and deal with your attacks appropriately. So, a bit of a conclusion. Not only having a security policy, but validating that what you think you're doing is actually doing what you think it's doing is kind of critical. It's a two-part approach. You can have your SSH key process, but unless you actively check that isn't being breached, you're perhaps living in ignorance. And that was one of the first highlights of putting in this tool. We didn't know that every single one of our Windows machines was getting about 1 million attacks a day. I suspect if you've got a Windows PC at home, anywhere connected to the internet, you're probably getting a similar amount on your home devices. Perhaps slightly smaller, but my home device gets between 500,000 and 600,000 because I've stuck this on my home PC for interest. So again, turning off your firewall perhaps isn't necessarily the greatest idea at home either. So thank you all for coming. If you've got any questions, feel free to ask me now or catch me. I'm here for the week. And feel free to come and contribute. We're always welcome more hands, please. Yes, it's a relatively small server application. I use that word very loosely, by modern hardware standards. There's a couple of installation options available, but I run it as an all-in-one install on a single. Tends to like a lot of disk space, depending on how many machines you've got. And it tends to like memory. Again, the more machines you connect to it, the more the central server has to do. It consists of 3 elements: an indexer, the dashboard, which doesn't do a lot, and then the kind of back-end storage piece.
So is it a daemon on every machine?
Because host-based intrusion was deemed to be our only way of monitoring our machines effectively, because we can't put things at gateways, whereas if all your infrastructure is behind a single access point, you could monitor the access point and block there. At Adoptium, our infrastructure's across 20 providers maybe. Fitting in a block at each point is not really the thing, so monitor on each host. And Wazuh, open source benefit is it's supported on a lot of platforms. The source is available, and you can get it to build on other ones as well. But we've not I think S390X is the only platform we've had to build from source, and it's been relatively painless, he says, after the first time.